Okay, this is a quick review of what we have done so far this week with math. And I just wanted to make this video so that if you are confused or you missed any of the sessions, this will help you hopefully to understand what we're doing. Okay, so to begin, this is called an array. Okay, so this is called an array. Okay, so we have columns and rows. And when you write a multiplication problem to represent this array, you are doing rows times columns. Okay? Now, this whole array has 1, 2, 3, 4, 5, 6, 7 rows and 4 columns. So to write that as a multiplication problem, we say 7 rows times 4 columns. Okay? We could, if we wanted to do the repeated addition, do it this way, but we're talking today about how to write it as multiplication. Now what they did here is they broke this big array into 2 smaller arrays. That's why this is called the break apart strategy. Okay, so they broke it into 2 smaller arrays because in this example, maybe the student knew their 5 facts, but not their 7 facts. They knew their 5s and their 2s. So they said, if I break it this way, then I have 5 rows of 4 and 2 rows of 4. Now, when they get done figuring out what 5 rows of 4 is and 2 rows of 4, they'll have to add it up to get the total array. So 5 rows of 4. So I can do, if I wanted to do it by 5s, 5, 10, 15, 20, or I can do 4, 8, 12, 16, 20. So this one, the product, remember that's what the answer to a multiplication problem is called, product is 20. And then I have 24, 28, or 4 and 4 more, which is 8. So 7 times 4 is 28. 28. Now this is called a number bond. Okay, so it's like the break apart because you start with your whole multiplication problem and you break it into 2 smaller ones. So we take this factor, 7, and I think of what numbers add up to 7 because that's how I'm going to decide to break apart. Okay, that's how we did 5 and 2. 5 plus 2 equals 7. So to represent that array that we have there, we would put 5 times 4 and 2 times 4. Okay, so this 7 times 4 was broken up. 5 and 2 is 7. Okay, so let's look at something else we did. So then we talked about how to write equations that represent these number bonds and break aparts. So this one we have, let's talk about again rows times columns. Rows, 1, 2, 3, 4, 5, 6, 7. 7 rows, 1, 2, 3 columns. So this array, the whole array is 7 times 3. This part they did 1, 2, 3, 4, 5 rows times 3 columns. So that's what this part of it is. And then this part is 1, 2 rows times 3 columns. So this is 2 times 1, 2, 3. This is 1, 2, 3. This is 5 times 1, 2, 3. And then when that is written as a We have our whole multiplication problem here. They broke up this 7 into 5 and 2. Okay, the whole 7, they took it 5, 2. And then they did 5 times 3 and 2 times 3. So that would be 15 and 6. And then you would have to add them up and get 21. So here, and we did these together, so if you were with me, this should not look unfamiliar. Okay, so what they did is they took these two, something times 3 plus something times 3 equals something times 3. So what they did is 5 times 3 plus 2 times 3 equals 7 times 3. 5 times 3, that's what I just did on the number bond. I put 15 plus 6 equals 21. Then yesterday we did bar models, okay? Sometimes you hear them called tape diagrams, okay, because it looks like a tape. So we're going to build a bar model to match this array. So we have to first figure out what this array is representing. We have rows times columns. Rows, so I have to count my rows. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rows. And in each row, and there are 1, 2, 3, 4 columns. 10 times 4. Okay? So, if I have 10 groups of 4, I have to take this bar model and break it up into 10 groups. And they don't have to be exact. This isn't a fraction, so they don't have to be exactly equal. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And in each group, there are 4. Okay, so we're figuring out 10 groups of 4. Now, we can skip count to figure it out. We can go 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. 10 times. And sometimes they write it down like this. They'll go like this, and then they'll have 10 times 4 equals 40. Or sometimes they'll write it on the top, the total, 40. Okay, this is representing this. And again, I told you yesterday, if you're still wanting to do dots, you can do dots in each box and then count them, but that's going to take you a long time. And this is the last one we're going to do. Okay, this is the last one we're going to do on this video to review. Okay, this was what you had as a word problem, and only a few of you did the word problem. So if you watch this, you'll, and I had a video on there of the word problem. Arthur has 4 boxes of chocolates. 4 boxes of chocolates. Each box has 6 chocolates inside. How many chocolates does Arthur have all together? Draw and label a bar model to solve. Draw and label a bar model to solve. So I'm also going to add an equation to this and an answer statement because I ask you for that in every word problem. He's got 4 boxes of chocolate. 4 boxes. And I'm going to represent his 4 boxes of chocolate right here. And in each box, there are 6 chocolates. Now I can write the number 6. I can draw 6. This is representing his chocolates. And it says, how many chocolates does Arthur have altogether? So draw and label a bar model to solve. So what we're going to have to do is we're going to either go 6 plus 6 plus 6 plus 6 equals his chocolates, or how many groups of 6? 4 times, yes, 4 times 6. I thought I had something wrong there. So we can do skip counting, and we can say 6, 12, 18, 24. If you knew 6 times 4, you could say 24. And so this is 24 chocolates. This is showing 24 chocolates. So this is what's called an equation. This is what's called an equation, and our answer statement is he has 24 chocolates. So if you did not understand arrays this week, or how to break them apart, or what a number bond is, or a bar diagram, this was a quick review of that.